We represent points on the Cartesian coordinate system, or also called the rectangular coordinate system, with ordered pairs. This is the same as a distance from the origin and an angle from the x-axis, just like points on the unit circle. Now, using the second definition of coordinates, we get what's called the polar coordinates. And it's written in this form, r theta. So instead of x, y for Cartesian coordinates, we now have r theta. R is the distance from the origin. So kind of like on this graph here, like this is the origin point. R is the distance from the origin, and theta is the angle from the x-axis. So theta is always going to be from the positive x-axis here and going around. So you can see that this point here is x, y, has an x coordinate, some distance in the horizontal direction, then some distance in the vertical direction. That's x, y, that's the horizontal, or that's the rectangular coordinate system. And the polar coordinates is going to be a distance from the origin with an angle that defines that point. So it's the same, it's describing the same point, x, y, r theta, they describe the same point. Now, if r equals 1, this is actually the unit circle, because theta can be any specified angle, on the unit circle. And typically for polar coordinates, usually the angle is in radians, not degrees, but it can be in degrees. Now, the conversion between these two is quite simple. We're just doing right triangle trig on this. This is the reference angle. It's the same thing as theta. And you can see that if you want to get x, for instance, x is going to be the adjacent side. So we're going to use cosine. So x equals r cosine theta, and y equals r sine theta. So right, what y is the opposite. So we're going to use sine there. And then rectangular to polar, really what we're looking for here is using the unit circle definition. That's really what all this is. R squared equals x squared plus y squared. And then tangent angle theta, right? Opposite over adjacent, y over x. That's how we can get the angle from it. So you can get the radius from x and y. You can get the angle from x and y. That's how you convert between from rectangular to polar. So r can be any real number. It doesn't have to be restricted to the unit circle. But negative numbers, we need to understand how does r change with that negative number. The best practice is always to write r greater than 0. So always be positive, but that's not always the case. And always you want to have theta between 0 and 2 pi. Again, that doesn't have to be the case, but that tends to be what you want to always write it as. Now, if for r less than 0, we're going to go in the opposite direction that the angle pointed us. So whichever way you would go, you're going to go the opposite. So back up here, right? This is where the angle is pointing us this way. A negative r would go the opposite way of that angle. That's the idea. Now, polar coordinate 1 pi over 4. This is the same thing as the 45 on the unit circle, right? This is a unit of 1 out from the center. Well, that's what the unit circle is. And pi over 4 is the same thing as 45. So 1 pi over 4 is the same as cosine pi over 4, just going to give you root 2 over 2. 1 times root 2 over 2 is root 2 over 2. That's the x coordinate. And the y coordinate, very similar. R equals, y equals r times sine theta. Sine theta is just pi over 4. So we get root 2 over 2 times 1, just root 2 over 2. So 1 pi over 4 is the same as root 2 over 2, root 2 over 2 in rectangular or the Cartesian coordinates, the normal coordinates you're used to working in. Now the point negative 1 pi over 4, this does not go in the forward direction like you would expect for this one. It's going to go in the opposite direction. So if this is 1 pi over 4, this right here is the polar plane. It's just a different way of describing it. The other plane that we were used to seeing is the Cartesian, and it's always got these rectangular, right? It's rectangular things like that. And that's why it's called the rectangular system. But polar, you're really talking about angles and distances from 0. So that's what this really shows you. The lines are the distances from 0, and the angles are shown there. That gives you an idea of what to look for. So negative 1 pi over 4, instead of going forward, from this is the pi over 4 angle, instead of going forward, we're going to go backwards. And we're going to hit this point here. That's negative 1 pi over 4. So really, this is actually the angle 225. Or 5 pi over 4. It's the same thing. And if you plug this into the conversion back to the rectangular coordinates, we're going to get 1 times 5 pi over 4. That's going to give you negative root 2 over 2 for x. And then 1 times sine pi over 4. That's going to give you the also negative version of root 2 over 2. So this is equal to negative 1 pi over 4. These are the same coordinates in rectangular and polar coordinates. When we're converting between rectangular to polar, right, we have this equation, r squared equals x squared plus y squared. And to actually solve for this, we have to take a square root of r. Whenever you take a square root, you get a plus or minus version. The issue is that here we're getting two different coordinates for one coordinate. There should be no ambiguity, but there is just a little bit in polar coordinates when you're trying to find them. So you always have to keep in mind where or what quadrant the point is that you're talking about, because that's going to dictate whether or not you get the plus or the minus version for this r squared. The same thing is true for tangent of theta equals y over x. When you take the inverse tangent of this, inverse tangent only goes from negative pi over 2 to pi over 2. That's the domain of one of the blocks of tangent, like this. But we can have any angle from 0 to 2 pi. So you have to keep that in mind when you're talking about converting from rectangular to polar. Let's take a look at that here. So first off, we're going to plot these points. We're going to give them equivalent polar coordinates that are the same, because you can actually have the same coordinates but different representations in polar. In rectangular, it's not the case, unless you're talking about like fractions versus decimals, but that's not really the same. That's not really what we're talking about. But there is some ambiguity in polar. So let's look at that here. So first off, 3.5, 7 pi over 4. 3.5 is going to be, well, if this is 2, this right here is going to be 1. Here's 3. And 3.5 is going to be on this circle here. And then we're going to look at 7 pi over 4. Well, 7 pi over 4 is, let's see, right here. It's this 45. So 3.5 is going to be along this circle all the way around until we get to this point right here. So I can draw a line out if I wanted to. I don't have to. I can just draw a point, right? But the line out tells me that this is 3.5, and going all the way around, we get 7 pi over 4. Okay, so that's the correct point. This is, once again, 3.5, 7 pi over 4. A point that's equivalent to this would be the same thing as 3.5 negative pi over 4. So instead of going in the forward direction, now we're going in the opposite direction, going down to here. This is negative pi over 4, and 3.5 out. That gives us the exact same spot. As well, we can do 3.5, negative 3.5. And in this case, we're going to go negative 3.5 is going to be the opposite direction from this. It's going to be this one. And that angle is, let's see, 3 pi over 4. So we're going to have 3 pi over 4. So these are all equivalent points. They are different in what they mean. Like negative pi over 4 is in some ways a unique representation of this point. So there's different representations of the same point. And that's one of the issues with polar coordinates. However, we tend to like to have r greater than 0 and 0 less than or equal to theta, which is less than 2 pi. That's the reason why this stipulation was there, because when you're talking about this angle, these conditions, there's only one way to represent the any point in polar coordinates using these conditions. So what I have written here first, this is the best way of writing it. Okay, let's convert this to rectangular coordinates. So first off, we're going to have x equals r cosine theta, right? That's going to be 3.5 times 7 pi over 4. 7 pi over 4 is going to give you root 2 over 2 times 3.5. Well, that's just going to be, let's see, there's lots of different ways we can do this. You can just write it as 3.5 times root 2 over 2. That's one way of writing it. You can actually get an approximation, whichever way you want to do it. Now, the other coordinate is going to be y equal to r sine theta. So it's going to be 3.5 times sine 7 pi over 4. 7 pi over 4. Sine 7 pi over 4 is going to be, again, root 2 over 2, but this time it's going to be negative because we're going downwards. So it's going to be negative 3.5 root 2 over 2. So this is the same thing as the rectangular coordinates. 3.5 root 2 over 2, negative 3.5 root 2 over 2. And of course, you can, approximate that. You can get it so that there's no decimal in the fraction. Whatever you want to do. It's all the same, but this is the coordinate. Okay, for this next one, this is 4 negative, let me clean this up a little bit here. 4 negative 135. Now, negative 135 means you're going the opposite direction, and that's going to be, I believe, right here. It's going to be on a 45, and it wants to go out to 4, so 4 is right here. So that's our coordinate right there. Now, this, of course, isn't in the standard polar form, so let's go ahead and write that in that way. That would be going to this point here. All the way around is going to be still going out 4 units, and all the way around in the positive direction for the angle, that's going to be, let's see, 5 pi over 4. And that's the standard way of writing that angle. Now, x is going to be r cosine theta, so 5 pi over 4. That's going to be 4 times cosine of this is going to be, it's pi over 4, so it's a 45. That's going to be negative root 2 over 2, which gives us negative 2 root 2. And y will actually be the exact same thing. Sine of 5 pi over 4 is going to be negative root 2 over 2. So that gives us negative root 2 over 2, or sorry, just negative root 2, negative 2 root 2, negative 2 root 2 is the rectangular coordinates of that polar coordinate. Okay, let's look at the next one. Next one is negative 1.5, 4 pi over 3. So we have a negative radius. So let's find the angle first, 4 pi over 3. That's going to be 3 pi over 3 is 180 degrees. 4 pi over 3 is going to be, oh, it's right here. It's actually written right there. So we know it's going to be this angle. And because it's negative 1.5, instead of going this way, we're going to go the opposite way. Negative 1.5 is going to be right here. So that is negative 1.5 4 pi over 3. Okay, this of course isn't in standard notation. The standard notation would be to go along the positive angle and have r greater than 0. So that's going to be the same thing as 1.5, and this angle here is just pi over 3. Okay, let's write this in Cartesian coordinates, or the rectangular coordinates. So we have x equals 1.5 cosine pi over 3. Cosine that is going to be 1/2. So we're going to get 1.5 over 2, which is the same thing as 0.75 or 3 over 4. Same thing. 1.5 times sine pi over 3. This is going to be root 3 over 2. So it's going to be 1.5 root 3 over 2. So the coordinate's going to be 0.75, 1.5 root 3 over 2. That's the rectangular coordinate of 1.5 pi over 3 or negative 1.5 4 pi over 3. Same thing. Okay, finally, we have negative 1, negative 90. Now, negative 1 means we're going to go the opposite direction of that. So let's find the angle first. The angle is 90 degrees. 90 degrees is going to be a right angle like this. So I'm going to be right here on the negative y-axis. But the radius is negative, so it means we're going to go upwards. And that's going to be right here at 1. So that is negative 1, negative 90. This, of course, is the same thing as 90 degrees. 1 out. I can write 90 degrees here, or I could write pi over 2. Both the same thing. So that's going to be negative 1, negative 90 degrees. And the rectangular coordinates of this is very easy. This is just 1 up. It's 0 left or right and only 1 upward. That means this is the same thing as 0, 1 in rectangular coordinates. Okay, give it a try in number 1. Now, for this next set, let's plot the following with rectangular axes, and we're going to convert it to polar coordinates, just to kind of do it, the other way. So here we have 4, 2, right? 4, 2 is just right here. Again, you can see how this is why this is called rectangular, because these are all squares, everything's in rectangles, depending on how you stretch it or shrink it in the horizontal or vertical direction. But that's the first point, 4, 2. Now let's write it in polar coordinates. So first off, we have r squared equals x squared plus y squared. That's going to be 4 squared plus 2 squared. 16 plus 4 is 20. So r is going to be plus or minus the square root of 20. Now, we are always going to have r greater than 0. So we're going to never choose the negative one, because we want to have it in this, always in this standard form. So we're going to have plus 20, plus root 20, and root 20 breaks down into 2 root 5. And now we have tangent theta equals y over x. Y is 2, x is 4. So the inverse tangent of 1/2, plug it into a calculator, that's going to give us 26.57 degrees, or you can also do it in radians, whatever you want to do. So this is the same thing, rectangular is the same thing as 2 root 5, 26.57 degrees. Of course, we've approximated the angle, so let's go ahead and approximate the radius. 2 times root 5 is going to be about 4.47, and 26.57 degrees. That's the polar coordinate. So what this means is that this length here is going to be 4.47, and this angle here is going to be 26.57 degrees. Okay, let's look at the next one. Negative 5, negative 8. Negative 5 is here. Let me scroll down just a little bit. Negative 5, negative 8 is going to be right here. So this is the same thing as, let's do r equals the positive square root of x squared plus y squared So give us 25 plus 64. It's going to be the square root of 89, which is approximately 9.43. And tangent inverse, so let's go ahead and do it like this way. Theta equals tangent inverse of y over x. So just 8 over 5. Plug it into a calculator. Gives us 57.99 degrees. And this should be shocking to you in somewhat, because 57.99 degrees, that's right here in the first quadrant. But we know it's not in the first quadrant, it's in the third quadrant. So I just graphed it on my rectangular plane. So we know that the reason why this is the case is because tangent, the inverse tangent, will only ever find you points in these two quadrants. This is going to be in negative angles, and this one's going to be in the positive angles, but it will never find points over here. We know it's over here, however. So the way we can find that is that this is 57, this is about 60 degrees up. Well, that means it's also going to be about 60 degrees from this line here. This is just about 60. It's 57.99. Well, this is the same thing as 180. So that means that our angle is actually going to be plus 180 degrees. So it's going to give us 237.99 degrees. That's the correct angle for this problem. So this is the same thing as 9.43 approximately and 237.99 degrees. That's how we find it when the tangent doesn't fit the right angle. Okay, so that's going to be -5, -8. Okay, the next one is 0, -4.7. 0 means we don't go left or right. We go down to -4.7. That's just about here. And we could do the polar coordinates of this. We could do, r squared and all that stuff. But we don't need to, because we already know the angle. The angle is going to be 3 pi over 2. And the radius, well, this is actually a straight line here. So we actually can find the radius by just looking at what's the distance of this line. And that line is 4.7 long. So 4.7, 3 pi over 2, or 270 degrees, same thing, is the correct polar coordinates of that point. Okay, next one is -2.5, 2.5. That's going to be here, here, just about. Let me write the coordinates here on this one. 0, -4.7. This one's going to be -2.5, 2.5. This one is actually also another easy one to find. You could, of course, do the r squared tangent and everything like that. This one's actually at a 45 angle because it's the same coordinate, the same numbers. The absolute value is the same. So I know it's going to be right in that 45 degree line. In this case, it's going to be 135 degrees or 3 pi over 4. But let me actually show you that with the tangent again, because this is going to be another one of those cases we have to consider. So we know this is going to be 3 pi over 4 or 135 degrees. Same thing. Okay, so tangent inverse, that's what theta equals, of y over x. Y is 2.5. X is -2.5. Plug that into a calculator. That's going to give us -45 degrees. -45 degrees is along this line here. But we know that this is the opposite direction. So we're going to find that the -45 is the same thing as this angle here, -45. So all I have to do is take the full angle, which is pi, or 180 degrees, minus the 45, and that gives me 135, which is exactly what I want. So it's really all you have to do is figure out, do I need to add or subtract it from pi or 180 degrees? and that'll give us the correct angle. Now r we do need to find. It's going to be 2.5, negative 2.5 squared plus 2.5 squared. And doing that on the calculator gives us 3.54. So this length here is 3.54. Okay. That gives us the polar coordinates, 3.54, and then I'll do 3 pi over 4. This is the exact same thing as negative 2.5, 2.5. Give it a try in number 2.